to turn to using the census and the America Community Survey to show you some household data. And this data, Pete's great about getting all these obscure data sets that you have to jump through hoops, to get. I'm not like that at all. I get data that's relatively easy to get. And so, the Penn table is very easy to get. It turns out all this individual data in the census is amazingly easy to get. And a lot of these micro data sets that are used are, especially for people, are pretty easy to get. So I'm going to talk about two of our papers, the allocation of talent, and then a new paper that we're working on, race and economic well-being in the United States. So this allocation of talent paper, as I mentioned, is with Chang and Eric Hurst and Pete. And it's motivated by another key fact, again, that's just, it's you kind of know it's true, and yet it's good to be reminded that it's true. So look at the United States in 1960. In 1960, and I'm going to round the numbers, 95% of doctors and lawyers were white men. 95%, 86% of managers were white men in 1960. Whereas by 2008, it was more like 60%. So my favorite example of this, but there are many, is Sandra Day O'Connor. So Sandra Day O'Connor is the first woman Supreme Court Justice of the United States. She graduates from Stanford Law School in 1953, number 3 in her class. So clearly a brilliant, talented person. First woman Supreme Court Justice, number 3 in her class at Stanford. She can't get a job in the private sector except as a legal secretary, right? Ruth Bader Ginsburg, same kind of story, right? In closer to home, David Blackwell. So David Blackwell of Blackwell's contraction mapping theorem. I won't tell the story. I'll let you Google it afterwards. David Blackwell eventually became a professor at Berkeley, but because of discrimination, it was a long time coming before he became a professor at Berkeley relative to what should have happened. So tons of discrimination and barriers, and you just see it in the numbers. It jumps out at you when you look at the numbers like this. So here's just another version that it applies across high-skilled occupations more generally. Let me skip that graph now. So the question we ask in this paper is the following. Suppose you think the distribution of talent in these high-skilled occupations is identical for whites and blacks and men and women, right? Well, what that means is in 1960, there were all these crummy marginal white men, white men at the margin, who shouldn't have been doctors and lawyers, and instead Sandra Day O'Connor should have been taking their jobs, right? That's what should have happened, and yet there were barriers that prevented that from happening. And yet, over the past 50 or 60 years, evidently those barriers have changed somewhat because the allocation of talent has improved. That's what the red bars are here, or that's the 60% number here. And so obviously this is a growth paper. So what we ask is how much of growth between 1960 and 2010 was due to this improved allocation of talent, okay, due to these declining barriers. And here's an example of how we sort of, uncover the barriers. So what we've got on the horizontal axis is the propensity of white men versus white women to be in an occupation. So you can see and this is in 1980. In 1980, women are 64 times more likely to be secretaries than white men. But if we look over here at lawyers, that's at about 1/4. Young women were 4 times less likely to be a lawyer than white men were. And so, they're 256 times more likely to be a secretary than a lawyer, right? So enormous differences in quantities. 256 times more likely. And yet look at the wage gaps. The wage gaps are both 30% for those two occupations. More generally, the wage gap is uncorrelated with these relative propensities. And what this tells you, and the lawyer secretary example is really good at illustrating this, the wage gaps for lawyers and secretaries is the same. Women get paid 30% less than men by simple measures, not controlling for a lot of things. But the propensities are 256 times more likely. So if you want to see these discrimination across occupations, you want to look at quantities and not prices, okay? And so the way we're going to back out the barriers is we're going to say, look, in a world with no misallocation, you'd expect 50% of lawyers to be men and 50% to be women. The population shares 50% of secretaries to be men, 50% to be women. To the extent that the data don't look like that, we're going to back out the barriers, these TALs that Pete highlighted before, that must be active in order to prevent women from being lawyers and forcing them to be secretaries in some sense. Okay, so we write down a model, we do all the calculation. What's the bottom line? The bottom line is the growth differences are really big. So actual growth in GDP per person between 1960 and 2010 was 1.7%. This is census numbers, so that's why it's not the 2% number. But had the barriers been unchanged, if we kept the barriers at the 1960 level, growth would have been only 1%. So the difference is 0.7 of a percentage point or 40% of growth. So 40% of growth in GDP per person, according to our calculation, is explained by this improved allocation of talent. 24% of GDP per worker and 90% of the rise in labor force participation, which is obviously due predominantly to women. And here are earnings numbers as well. Let me skip over that now. It looks like it's mostly human capital frictions instead of labor market frictions. It might be like 60-40 in our benchmark calculation, I think. Okay, then finally, the last project I want to talk about is this new project in progress. I think we just posted a working paper and started presenting it over the summer at the NBER. It's a paper with Pete and with a graduate student at Stanford, Jean-Félix Bruyère. It's on race and economic well-being in the United States. And again, using census data and other sort of publicly available micro data sets that are really easy to get. The idea here is to apply this beyond GDP paper that I just showed you. Instead of applying it across countries, let's apply it to different groups within the United States. So let's ask, what's the consumption equivalent welfare differences between blacks and whites, or between white Americans over time, black Americans over time, across groups and over time? We're going to include consumption, life expectancy, leisure, and inequality again. And we're in our robustness checks, I won't show you them today, or our extensions, I should say. We include treating unemployment differently, looking at incarceration rates. Those don't make huge differences. The health quality differences, morbidity differences, that makes a pretty big difference. Those show up as being important. So here's consumption per person imputed from census data. So we use the CEX, I'll show you some CEX numbers in a second, Consumer Expenditure Survey, to figure out, if we see your income, how much consumption are you doing, and then we apply that to the census data. So we can go all the way back to 1940, and you can see, the gaps are closing somewhat between blacks and whites in consumption, but it doesn't jump out at you that it's closing a lot, right? There's been lots of growth in both, but the gap's not closing maybe as much as you might have thought, or I don't know. I'll show you exactly the gaps. Here's the gap in life expectancy. There you see much more of a closing of the gap. So life expectancy for Black Americans in 1940 was just 54 years versus 66 years in the US. So something like an 11 or 12 year gap. And by the end, it's, sort of 5 or 6 year gap, I think. So life expectancies close the gap a lot. So here's our consumption equivalent welfare number. What this says is in 1940, Black Americans had a consumption equivalent welfare of about 28% of what whites had. And that by the end, this is more like 2/3. Right, so the 2/3 number, I think you can see it in two different ways, and it's okay to have both of these things in mind. That's what I think you want to see. The gaps are still large. 2/3 of white Americans today in 2019, right? So there's a big gap between blacks and whites. I'll show you the decomposition in a second, where it comes from. 2/3 versus 1, so a 33% gap today, but the gaps were much, much larger historically. So there's been enormous progress, but there's still a lot more progress to be had. I think that's the picture you want to take away from this. Okay, here's the decomposition. You can see, consumption's closing the gap a little bit here. This doesn't really tell you. I forget the exact number. It does close the gap somewhat, but a big piece of the closing gap is the life expectancy piece. We don't have the inequality numbers here. We do it when we do the CEX numbers, but the leisure and inequality numbers are pretty small. They're not a big piece of the story. It's really life expectancy first, and then consumption second. This makes another important point, which is that so what am I doing here? Look at consumption per person in the United States in 1940. Call that 1. By how much did consumption per person in the United States rise to today? It's a factor of 5. We're 5 times richer on average, measured in consumption per person units, than we were in 1940. That's economic growth. That's wonderful. It turns out when you add in the gains from life expectancy, you get much, much bigger numbers. So for white Americans, rather than this 5-fold increase for all Americans in consumption equivalent welfare for white Americans increased by a factor of 13. So 13 instead of a factor of 5. And for Black Americans, consumption equivalent welfare increased by a factor of 29. So I think the factor of 29 works out to be a growth rate of about 4.5% per year. The factor of 13 works out to be like 3.3% per year. And 5 times is something like a 2% per year growth rate. And so you can see the US economy has grown much faster when you add in these gains to life expectancy, because again, each year of life expectancy is worth about 5% of consumption, and we've added a lot of years of life expectancy. And so those are incredibly valuable. That's kind of one of the themes I would say that shows up across a range of papers that I've worked on related to this topic. Okay, I have 2 minutes. Let me talk for these 2 minutes about the data and where you can get it from. Again, the chadmatlab.zip file has a bunch of the functions that you can call. So if you go to this web page, I won't click through and show it to you. It's remarkably easy to use. It's the IPUMS database, and they have all the census data. Annual census is back to, I guess, a long way back. We only used them back to 1940. You can get a login very easily. You can download the data. There's the American Community Survey, which after maybe 2003 or 2004, we started doing annual surveys that were smaller than the census, but they're stratified random samples. And so you can get annual data rather than just decadal data. You can get all these variables. So, household income or family income. You can get people's states and their zip codes. You can get how many people live in their household. Do they own their house or do they rent? Just enormous rich data in the census that you can download and manipulate however you want. Hours worked, obviously we use that to get our leisure numbers. You then view your cart, select the data, extract. One thing I'll say, and this is not obvious, so the census data sets are really, really huge. They're big. They're, even if you're playing with, I think the 1% or 5% sample, you could get in the hundreds of megabytes. And obviously, if you want more, you can get even bigger data. So they allow you to customize your sample size when you're downloading the data. And I really encourage you to do this. If you select a 0.01% sample, that's only going to be 3 megabytes. And then you can make sure the download worked, that it gave you the variables you want, that your program runs on the small sample. And then you can just go back and grab the 1% sample or the 5% sample or whatever you want and get lots of data. Do it for multiple years. So again, a program that I've included in the I guess it's on the Dropbox link, is this read census.m. And this tells you in MATLAB, again, which is what I tend to use, easy code using, I think it uses the table command. MATLAB, it's gotten more and more user-friendly because of competition from Python and Stata and things like that. And so the code for reading in large data sets and treating them like tables or the long and wide thing that you can do in Stata. I don't use Stata. Is really nice there. So what would I say is the bottom line? I would say some takeaways are tons of great publicly available data, for countries and for individuals. This kind of census data, or at least CEX kind of data or labor force survey data you can get for lots of different countries very, very easily. And then I think the other theme I would encourage you is Stata, for example, is horrible about plotting graphs. It doesn't label axes well. Really pay attention to your graphs. Something I always tell people is I think legends are evil. So when you have 5 lines in your graph, label each line individually. Don't have 5 different colors and the reader has to look down at the bottom and figure out what line is what. That's terrible. Really care about making things easy for readers to incorporate.